Thank you very much. So can you hear me in the back? Well, it is plenty on. So I think the last time I stood on a stage like this in a venue like this, I was 10 or 11 and was in a Christmas play. And then I played the backside of a camel. Yeah, so hopefully I can step it up from that. So my name is Tomas Mellgren. Been a part of the TailF team for a long time, since 2008. During the majority of that time, I have been heading up the engineering team, but since a year I have been voted off the island and live in San Jose, more as a CTO type role for the TailF group. So what we will talk about today is what to think about and how to approach NSO in brownfield deployments. And someone fainted in the back when they heard that. So pretty much every brownfield or NSO deployment starts in some kind of brownfield environment. We of course sometimes see greenfield where everything is new, but pretty much always. And what that means is that we have existing systems and processes for configuring the network and multiple systems and humans actually touching the devices. And that is not something bad or wrong, but it's something that it's important that you spend time and do the analysis of the environment and understand what you're trying to put NSO into. And especially when you have out-of-band changes in a brownfield deployment, it's something, if not approached and done correctly, it's something that can have a very big effect on performance and characteristics of the entire stack. So the focus is. So if you talk about brownfield deployment, it can mean a lot of things, but I will mainly focus on the out-of-band part of this. So I'll start with some terminology. I'm used to being able to point to the picture, so we'll see if I can jump. But this is a picture that will return throughout the presentation. So I thought I'll sort of go through the terminology and the moving parts here. So we have NSO within the dark blue circle. A is the service instance data that is provisioned in NSO. We have B, that is the representation of the device configuration in NSO. We have C, that is the actual device and the configuration on the device. And we have D, that is the mapping logic. Whether it's Java, Python, or XML templates, it doesn't matter for this presentation, but those are sort of the moving parts that we will talk about. So what is an out-of-band change? In the context of this presentation, in the context of NSO, I typically talk about the band changes when there is a human or a system that configures a device outside of NSO, without the knowledge of NSO. So it can be done something that is done sort of in a controlled manner that we know about, or it can be in an uncontrolled manner, and we'll deep dive into sort of the different types of out-of-band changes. But that is what I mean with out-of-band changes throughout the presentation. And again, this is a very common scenario, so the idea here is to be able to categorize it and understand how you should approach it, both from a sort of a project point of view, but also from a feature point of view when it comes to NSO. So when we talk about out-of-band changes, the most important thing is to analyze and understand what is the current situation that you have. Are you in a situation where you have no out-of-band changes? Are you in a situation where you have some out-of-band changes, but they are unrelated to NSO, that you have multiple systems doing it in a controlled manner? Or are you in a situation where it's completely out of control? A lot of them, random people, systems overwriting each other. And we see all of that. and you just need to understand where you are at so you can approach it correctly. And you definitely need to have a vision of where you want to end up. Are you happy being in number 3 here, or do you want to transition into more of an environment where you can automate things? So I typically talk about sort of the automation journey, and I think this was mentioned in Colin's keynote earlier today, and I think it's sort of a common theme that we heard from the reference cases from Telia and others this morning, where there is an entire scale of how sort of mature your environment is to be able to automate. And if you look to the left here, we have an environment with humans and processes configuring devices at random or in an uncontrolled manner. There is no sort of central view or processes. It's a very distributed from an operational point of view. There is probably lacking sort of central authority or resource management, VLANs, IP addresses, or whatnot, and the systems or humans that provisions the devices are mainly working at the sort of a device level environment. And as we sort of go further to the left or right, we get into environments that have a higher maturity with sort of a utopic nirvana end goal here, where everything is under control. We have full automated services lifecycle and operational procedures, and all write operations towards the network are deterministic and under control. That doesn't necessarily have to mean that it is NSO that does everything, but everything is done with care and control. And then, of course, we have an entire range of different variations in between. It's not something inherently wrong, or there's no right or wrong where you are here. But you have to understand where you are, and you have to understand sort of the limitations that you have to live with on this scale. So I mean, we definitely have customers that lives in sort of the low automation maturity, that use NSO as a device power tool. They can safely use sync from. They use it more as a scripting, single pane of glass, and that might be fine, or it is fine. But of course, you will not be able to benefit some of the things that you could if you are to the right. So if you look at the sort of the feature set of NSO, we have a number of tools to be able to live and work in all of these categories. But of course, or I would say, as well as transition, typically customers start out somewhere to the left and want to get to the right. And they do that in a somewhat, hopefully, controlled manner. But of course, the more of these tools and the further to the left you are, it will typically come with the pricing complexity and or performance or throughput. So, don't know if I messed this up. So historically, I would say the main feature for ensuring that the configuration in NSO is in sync with the configuration on devices has been sync from. And I want to spend some extra time around sync from, because it is a common topic. We have, the last couple of years, added a lot of features for brownfield deployments, and we are continuing to do that. So I will deep dive on some of these features later in the presentation, but I just sort of want to set the scene and ensuring that there are plenty of features, and depending on where you are and the environment you have, there's a big toolbox out there to use. Sync from. This is a topic that comes up now and then, and I've heard there was a number of questions this morning, and it was very interesting to hear answers from other customers and how it's approached. So basically, I mean, what sync from is you tell NSO to fetch the entire configuration from the device and without any guardrails, overwrite the configuration for that device in NSO. So that, as the first bullet says here, I wouldn't recommend that ever to be used continuously within your sort of automation process. If you do, you definitely are you are in a situation where you are limited from sort of getting the full leverage out of automation, and it comes with both the price and performance and risk. So it can be very dangerous in the sense that you will today you will blindly overwrite the configuration in NSO, which means that you can easily overwrite existing services. I mean, if you've had a number of out-of-band changes out in the network that has overwritten existing service instances, you will blindly just overwrite those up in NSO, and you will have a situation where you are the service instance in NSO is out of sync. It is also a lot harder to actually sort of mitigate and understand the out-of-band changes that have happened, because if you have an out-of-band change out there that shouldn't be there, or perhaps should be there, but you want to identify exactly what it is, if it's just out on the device, you can use compare config to easily identify exactly what it is. Once you've just blindly synced it up to NSO, there are further steps that needs to be done to understand exactly what had changed. And it can definitely be slow. I mean, if you sync, typically, sadly, out-of-band change goes hand in hand with the size of configuration. Typically, you see it on these big aggregation routers or routers that have a lot of config, and syncing these routers or switches that have huge configurations, it takes a long time. Both that it's typically very, very slow for the device to give you the config, and of just parsing it and getting the information up in an NSO. And it's a blocking operation for that device. So you will, during that time, if you sync a big Alcatel-Lucent router or Juniper router or Cisco router, during the time of the sync, you will block anything towards that device. So it can limit the entire sort of provisioning flow. So don't ever use it if you don't know exactly what you're doing, and do it with care, and consider the alternatives, because there are plenty of alternatives. So let's look at the different types of out-of-band changes that we have, and look a bit on what type of tools that we should use if we look at alternatives for sync from. So I mean, again, utopic, best and easiest way and easiest environment approach. There are no out-of-band changes. NSO is the single point of authority. You just use sync from as the bootstrap operation. You get the configuration into NSO, and you're just good to go. Easy peasy. That's it's an easy operation. Controlled out-of-band changes. This is definitely an environment that I see as fairly common, and something that's definitely, I mean, it is not problematic, but you need to have good control and understanding of your environment. This is where you have NSO writing certain parts of the configuration, and you have other humans or system configuring parts of the configuration that is completely unrelated to what NSO reads or writes. So if you look at the picture here, we have the dark blue part is something that the NSO service writes, and the light blue is something that it reads. And we have the little red bars there, which is configured. It's completely unrelated or disjunct part of the config. Right. So, but if we know that we are in an environment where they are completely unrelated, that's where I sort of mean with this category. That you know that you perhaps have a system that configures the firewall rules, and you configure only the BGP process. So you know it's under control. And I'll get to the situation where you say where someone is nastier than that, and that's of course adds complexity. So in this situation, you basically tell NSO, it's okay to be out of sync. We have a situation where there are more than one entity configuring the same device. NSO configures some parts, another system configures some parts, and that's fine. We are okay with that. So one approach is to just disable the sync check. So you tell NSO to just roll with it. Sorry, say again? Yes, you can do it both on a per device and per commit and on the device profile. I'm nervously looking at the experts on the first row here. So on the device profile, but also on a per commit level, right? Yeah, I got a nod from that. And I mean, the advantage here is actually that it goes faster than a standard operation, because the sync check operation can, in certain cases, be fairly costly. If you have well-behaved devices that have a transactional ID, so you can see that, okay, something has changed, it's a single ID to get from the device, it's a fast. If you have legacy devices where there are no way for NSO to understand if the configuration has changed without retrieving the entire configuration and computing a checksum, it can definitely be a costly operation. So actually disabling the sync check, it makes it faster. But of course comes with the downside that you don't know. I mean, you rely on your knowledge that the environment is safe. And as the last bullet says, potentially you can use a feature called no overwrite. I think it was mentioned by the Telia guys this morning, and I'll get to that later here, as a sort of an extra security check or some guardrails to ensure that no one has been messing around with the stuff that you were working with. So far so good. I mean, so far we have well-behaved environments, and we'll get to some of the less well-behaved here. So in this situation, we have uncontrolled out-of-band changes that are write affecting. So here we have NSO writing again the dark blue piece of the configuration. We have other systems and humans, typically fairly randomatic, or it might be operational or just distributed operations that sometimes come in and write or changes values that NSO owns or wants to write. And in pretty much most of the cases, this is considered a sort of a catastrophic failure environment, that someone has messed with a service that should be provisioned by NSO. You have conflicting service views of the service in the world. So typically this is a situation where you want to flag and say, hey, we have a manual fallout. Hey, I need to do the analysis of why this happened. So no overwrite. I mean, of course you can, in this environment, run with the sort of the standard sync check and say, if something is out of sync on the device, we will stop and we will do a manual fallout, and someone will have to check what happens. But if you have the combination of perhaps controlled out-of-band changes that are okay, and the nasty system that overwrote the service configuration, no overwrite is a good tool. And what no overwrite is doing is it basically tells NSO to look at the chunk of configuration that the service wants to configure and ensure that isn't the configuration on the device now, and NSO's view of that configuration isn't different. That someone hasn't mucked around with the config that I want to write. And I mean, it adds some security if you have what you mentioned, some people that are not so well behaved in the operations team, but it will certainly also reduce the number of sort of failed service provisionings if you have other safe or control out-of-band changes as well. And just as I mentioned, I mean, if you have if this happens and if the sync check fails and you have an error, someone needs to look at it. If no overwrite fails, that someone has been touching that part of the configuration, NSO will flag an error, and you will have a situation where you typically want to do an analysis. What has happened? Who did that change? Why was the change made? And what should we do with it? And of course, here we have a number of different tools to look at. You can do check sync on the service to see if something has changed. You can do compare config to understand what exactly on the device has changed. This is another sometimes trickier case when you have NSO, again, the service computes and writes the dark blue part of the configuration, but it during the service logic, it reads the light blue part. And what the small arrow up in NSO there means what you do if you have in your service logic code that reads values outside what you want to configure, you will read that from the CDB representation of the device config. So if you then have another system or human doing an out-of-band change within that part of the config that NSO reads, you will actually have service logic that bases its logic on inaccurate information. And examples like this could be if you want to do some kind of validation or check that whatever you try to do is correct, or if you need to base your logic on other values in the configuration. And if you have this situation, you're typically you will get the wrong service output, and you have a tricky situation to solve. So here we have a feature called partial sync that was also mentioned earlier, and it's a more fine-grained version of sync from. Basically, you can give it a number of parameters to sort of say, okay, sync this part of the tree from the device. And it of course limits the effect that the full sync from has. At least you just read the small part of the config. You won't overwrite everything. It is, however, it sort of shares the dangerous side of sync from that the part that you specified, you will blindly take that and overwrite the config in NSO that you have. So it shares that, but at least you have a more fine-grained control of it. It's also important to remember that the performance of partial sync and the sort of the efficiency and the behavior of it will depend a bit on the available or how the device works. If you have a netconf device, for example, it's typically very, very easy to do a subtree filter and say, just give me this and this and this part of the config, and it's super efficient. Some CLI devices, you can do a show running config and get a certain part of the config, but some don't. Some you are limited to get very, very big chunks of the config, and then we will still sync only the part that you specified, but it will be in an efficient behavior. So you will sort of get the same performance penalty as you do with sync from. Another alternative, and this depends a bit on the type of service that you have and how, if you need to have those values in sync for other reasons, is to, in your service logic, instead of partially syncing the part of the config that you need and reading it from CDB, you will do a live status call directly to the device and fetch the value directly from the device momentarily. This can certainly be more efficient in certain cases, but it can also be less efficient if you do it often, and since you can of course cache it in your service code and do some cleverness around there, but if it's slow to get from the device, if you get a lot of values, etc., it can be more have a bigger performance hit. So that's sort of the vague answer. It depends, but that's where you have to do the analysis. What type of value, what type of operation is this, and measure, and how does the device behave. And I would say it's also very largely dependent on if is this value needed for something else? Is it needed for by other services, or is it okay to just fetch once? So what we talked about so far is mainly sort of how to handle out-of-band changes during provision time. When I provision a service, what do I do if something has happened before or during that? But of course, as I think I mentioned earlier, we have a number of tools to identify and work with out-of-band changes that have happened for existing service instances. You can do a check sync on your services to see are they actually in sync with what's out on the devices now. You can do a compare config. You can do check sync on the devices themselves. So there are a number of tools, and it's not uncommon that we see customers doing this periodically, sort of as a compliance step to ensure are my key devices out there that you want to keep in sync, of course, actually in sync with the NSO's view of the world. So what does it all mean? I thought I would be barraged with questions. We have plenty of time for questions here. But if there's something I want you to take away from this short presentation, is that sync from. Do it with care. If you have a process or a workflow or a provisioning flow that continuously do sync from operations, do the analysis of why you have to do that. I mean, it's definitely not an uncommon scenario that we see our customers starting there, looking at that sort of automation journey where you are, and then continuously analyzing what are the out-of-band changes that I have, why do I have them, should they be automated instead? Is it just someone that you should slap on the fingers and said don't do it, or is it something that just doesn't exist at all? Because of course there's definitely valid cases where you have humans logging into a device and doing something, but when you have humans or systems actually overwriting the same service, you have a split brain situation where you don't have a single view of what you have actually sold and put in your network. If you have a VPN service with a bandwidth that someone has paid for in a portal and you configure that from different places, what will you report to your BSS systems?
Migrate for people who are seeking to migrate services either in existing NSO deployment services or pre-NSO services. You're trying to migrate them from one system to another. What are the best practices for trying to build that
so is that question sort of related to so how do I get existing services into NSO that are there or in a legacy system? Or?
In a legacy system, or just migrating them from one device to another inside the suite. So I'm trying to do max for existing services. Provisioning's already done, they exist. What are the tools to change the service parameters from one device to another, or one interface suite to another?
If I think I understand. So I mean, when we talk about the entire reconciliation step, where you go into, okay, I have 10,000 VPN services existing in the network, I want to get that up into NSO. That's an entire afternoon in itself. I think Dan's going to cover some of that. Now I'm throwing you in front of the bus, Dan, here, at least in certain contexts. There's a number of tools, and I'm vaguely going to say, and also examples and documentation on that. The typical process there is you first sort of have to analyze, do I have all the information to actually create service instances for it? Is everything there in the network to actually understand? Do you have description fields that I can parse to understand this is all the configuration related to?
Or did I? I'm trying to more. say I have a router
Yep.
that I am decommissioning and I'm migrating all of those services to something else. Is there a better way than simply replace config across the entire network, or do I need to go back north and redefine from my circuit database? But what is the best way to address that use case?
So taking services from one device and putting it on another. I mean, if you have services in NSO and you have pushed the service towards the first device and you typically have some kind of device reference there, I would say that the simplest way is to, I mean, point to the other device and do redeploy of the service. So ensure that the new device is in sync. You start it up. You change the config parameter in the service to say I should be on device 2 instead of device 1, and you do redeploy. And that will typically, or that will remove from the first and push to the new one. Did that answer?
Follow up from my peer.
Good. Not a follow-up, change of direction.
Yep.
So if we're in scenario 3 that you defined with uncontrolled out-of-band changes, and so we're always doing a sync from before we commit a new service.
Yep.
And we want to move towards using no overwrite. Do we effectively have to do a redeploy no networking on all existing services to get the CDB devices branch into the idealized state so that it can compare to see when the overwrite's happening, or?
Oh, no. So let me see if I could follow there.
So I guess to simplify it, the no overwrite option, does that just compare the devices branch of CDB to the configuration in the field to determine whether something's being overwritten?
So no overwrite as it works today, it will run the service logic and look at the change set computed, and then it will compare that to what's on the device today.
Okay.
So it will fetch that.
Okay. So if we are currently doing a sync from all the time, we can just start using no overwrite out of the box, and it'll be able to handle that in stride. Okay. Thank you.
You might get into a situation where you get more errors if you have, but I would say that's the right path to sort of stop and start using no overwrite.
Perfect. Thank you.
Do you guys agree? I'm seeing some nods with the right approval here. And I mean, if I didn't manage to answer your question, let's continue in the over beers or something like that. But so just to finish off the first bullet here, it's typically a very good and sometimes slightly painful process to do exactly what you described here. Do the analysis of why you do sync from now. Do the analysis of why do you have the out-of-band changes, and understand why they're there, should they be there, should they be handled differently. But just sort of getting control of what happens is typically an eye-opener for many sort of operations. And that's a big step in moving towards that more nirvana situation, or at least more nirvana-ish situation.
I think I've done the analysis, but I'd love to be convinced otherwise.
Okay. Yeah, good. And so that basically covered the second bullet there as well. But and the last bullet here is that if you're a service developer and you're looking at performance of your service, which is a super valid thing to do, and we should profile the bejeebus out of your service and understand where time is taking. But you typically have to look at the entire sort of solution stack and do the analysis of all the steps that are taken. Typically, I mean, sync from is a big hurdle there, or thing that typically takes a lot of time. But there might be other things in the entire thing caused by brownfield deployments. There might be extensive pre-checks that needs to be done because you don't have that single sort of resource allocation authority, or there might be something else. So it's typically good to sort of look up and look at the entire stack. I think another thing that I'm just going to mention here, it's a bit out of scope here, is that a lot of these big devices have a lot of nifty NED settings where you can actually enable that speeds up the communication with the device in certain cases a lot. I mean, we have sometimes you can fetch the configuration using SFTP or SCP instead of during sort of using normal show commands, and that can immensely improve performance. So you have to look at the entire stack, and sometimes also the type of device to see where can I crank out the most of the performance here. So that was actually my last slide. I realized that I'm faster than planned. So questions? Good.
I'm glad that you didn't cover another alternative, which is a more destructive sync 2.
Right. Yep. I mean, sync 2 is of course. I mean, it basically is the reverse. It has the same scariness in that you just push, which might be okay if you see that I've had out a band change. Someone has definitely been nasty out there. I just want to ensure that the NSO's view of the world is the correct one, and I push that. You should definitely do some kind of analysis. What am I going to push? I wouldn't just blindly do it. That's for sure. And I mean, just as sync from, that's definitely not an operation that I would do sort of continuously automatically. It should be a manual mitigation tool. If you see that someone has messed around with all of this, I want to push a new configuration down. More questions?
Can we maybe get a menti.com poll for tomorrow, maybe? Because I'm curious with 70% service providers.
If this was better than the backside of a camel type
No. So I think Colin reported we've got about 70% of the customer base for NSO as service provider. So in that kind of a conservative, slow-moving environment, I'd be surprised if a lot of us aren't doing sync from, which obviously, if we should all be avoiding like the Black Plague, I mean, maybe some more collaboration needs to be done around how we can all get there.
That is a good suggestion.
One comment, I guess, I mean, the reason I think that many are using sync from is we told you to. And that's sort of how you learn it. So it's really the only way to get out of that sort of, hey, my device is out of sync. And so I think the premise of this presentation is to say, hey, we thought of some smarter ways of dealing with the problem that somebody's modified device, and you want to make sure that what you're doing is not sort of messing with that same thing, because that's the crux of the problem here. And the whole sort of being in sync was and is a fairly crude measure of that. I mean, it can only tell you that someone's messed with something. And so these are better tools now.
Yeah, and to that point, I think, I mean, definitely we also see that it's okay to be out of sync, and it's a very common thing. But then, of course, you need the tools and the guardrails to still being able to have a good automation environment in that. And definitely, to your point again, that this is an area where we have done a lot, and it's continuously a focus area. So I know one of the things that we have talked about, it's not planned for release yet. I mean, is to just have when you do sync from, now it just overwrites. You could potentially have sort of alarms or events to say, okay, I'm doing sync from. Tell me if NSO if I'm about to overwrite something that a service in NSO has written. That would be something. I mean, we have the information there, so that's definitely an enhancement that we're looking at. I don't dare talking about releases, but we have it on the list. 5.1. That's. Anyone else? Any other questions? I'm also super happy that I got the hour when everyone got jet lagged and started fading in their chairs after a cinnamon bun.
All right, thank you, Thomas. Very good.